Hello, my name is Daurena Muhammad. I'm a mathematics teacher in Nazarbayev Intellectual Schools of Physics and Mathematics in Almaty. Good morning, children.
Good morning, teacher.
Do you remember what we studied last lesson? Arithmetic sequence, yeah. It was a type of sequences, right?
Yes.
Today we will study geometric sequence. It is a topic of our lesson, geometric. How did we call arithmetic sequences also? Arithmetic progression, right. Geometric sequences also geometric progression. They're very similar. Like the last time, we have two goals. First goal will be to understand the structure of the geometric sequence. And the second goal, know the formula and be able to use it. Do you remember the structure of arithmetic sequence?
Yes.
Can you tell me?
The first term was z, we multiplied by the number of terms. -1.
Now you are telling the formula. Do you remember the structure? How do you receive the next term from the previous?
You add one number.
Every time you add a number. un plus 1. To receive un plus 1 from un, you
Plus D.
plus d every time. And the d was called common difference. Structure of geometric sequence is similar. It's like structure of arithmetic sequence, but now to receive un plus 1's term from un's term, we multiply by the same number r. For example, if your current term is 1 and you multiply by 2, what will be the second term? 2. And the third? And so on, right?
Yes.
D was called common difference. And now R, the number we multiply every time, is common ratio. Common ratio. Why D we call it common difference? Because when we subtract from un plus 1 un, we always receive the common difference. And now, every time we will divide next term to the previous, we will receive R, common ratio. That's why it's called ratio. Do you understand now the structure of geometric sequence?
Yes.
For example, if the third term of geometric sequence is 2 and the sixth term of geometric sequence is 16, what will be the common ratio? Okay, it's a hard question to answer. What will be the total ratio?
8.
How did you get it?
16 divided by 2.
Okay. How many steps did it take to get from the third term to the sixth term?
3 steps.
3 steps. Okay. And what was the number we multiplied every time to get 8?
I think 2.
So with 2 multiplied by 2 and received 4. We multiplied by 2 again and received
8.
And we multiplied by 2 the third time and received
16.
16. Good. The formula for nth term in geometric and arithmetic sequences are similar. For example, do you remember how we received the formula of the nth term in arithmetic sequence? The first term was a, the second term was a plus d, the third term was a plus 2d,
Yes.
and so on. So the formula was un was equal to
First term plus z
d, common
multiplied by
difference
n
multiplied by
minus 1.
n minus 1. N minus 1 steps. Okay, for geometric sequence is similar. If the first term will be b, the second term will be b multiplied by r, our common ratio. The third term will be b multiplied br multiplied by r, which will be br squared. And the fourth term will be br cubed, and so on. So the formula for the nth term will be b times r to the power of n minus 1. And it's very easy to remember, because when we have arithmetic sequence, we add number d n minus 1 times. And here in geometric sequence we multiply by r n minus 1 times. That's it. Okay, here's an example for you. We have a geometric sequence which starts by 1, 2, 4, 8, and so on. Find the seventh term.
Probably 64.
64. How did you get it?
At first I found the common ratio, which is equal to 2. And then I found the number of steps,
Which is
6.
6.
And used the formula.
So what was your expression for the seventh term?
1 multiplied by 2 to the power of 6.
Yeah, that's correct. Now we will play the game. We played it once or twice. You'll have a list of problems. You'll solve each problem and try to find an answer here. There will be a letter. You'll solve all the problems in the right order, and you'll receive a phrase, several words, and who the first finds the answer is raise your hand. After theory, students need some practice. This time I gave them the worksheet contains problems and answers for them. There are about 25 problems, and when they solve a problem, they can find an answer and find a letter which is next to the answer. By putting all the letters together, they will receive a phrase. The basic human curiosity makes it fun for them to solve the problems because they are wondering what the phrase is. Solving the problems and checking their answers gives them confidence. If they have any problems, they can call me, and anyway, I walk around and see what students do and how they are doing. Students have different speeds in solving problems. So some students will finish earlier and some students will finish later. For those who finished earlier, I prepared additional work. These problems are more challenging. The differentiation gives more able students opportunity to learn some extra. That is what they require.
I did it.
What's your answer? What's your
So,
phrase?
solve the problem with review.
Well, it's a problem for you while you're waiting for this.
Okay.
Anybody else?
I did.
Hmm?
No?
Good. Here's a problem for you while you're waiting. Having real problems in the classroom helps students to connect the problems they solve in the classroom to the problems they can see in the real world. In that way, mathematics will be more relevant for them. You can find geometric sequences in many places in the real life. For example, this piece of paper. What is the format of this piece of paper?
A4.
A4, right. Do you know the length and the other side?
No.
Maybe like 20 or 30.
20 or 30. Yeah, it looks like 20 on 30 centimeters. Do you know how they choose this ratio? For example, if we have a piece of paper, A4 format, you can fold it on two and receive another piece of paper. What can you say about them?
It's A5.
2 times smaller.
Two times smaller, but what else?
The format of this paper is the ratio. The
A5.
ratio is
The ratio is the same? Do you think so?
No.
Is it? Looks like
Yes.
it is. It's just scaled. If we fold a piece of paper A4 format twice and then again, then you will receive again. It's a
Yes.
similar figure. That's how they choose the format. That's how they chosen the ratio. Try to find the proper ratio. Let A be the length of longer side and B be the length of the shorter side of A4 paper. If we fold it, we will receive A5 paper, right?
Yes.
Now what will be the length of A5 paper?
B.
B. And what will be the shortest side of A5 paper?
half of the
Half of A. And remember, the ratio of longest side to the shortest side should be the same as here and here.
Okay.
Try to write the equation.
square root of 2.
Square root of 2, yes. How did you get it?
I used proportion to find A.
What was your proportion?
And A divided by B equal to B divided by half of A. Then I find A divided by B and it is equal to square root of 2.
Good. Did you understand? In the end of the lesson, there was reflection. It gave students the opportunity to assess their knowledge if they achieved the goals of the lesson. And it also showed me some information on their understanding. The reflection time. The goals of the lesson were to understand the structure of geometric sequence, and the second goal was to know the formula and be able to use it. We think that he or she knows the formula of the nth term of geometric sequence and can apply it? Thank you. And who thinks that he or she understands the structure of geometric sequence? Great. Thank you for the lesson. See you next time. Bye.
Thank you.
Thank you for watching the lesson.